Nice. We don't have to even open the windows, but at least like move up the blinds.
All right, so remember this question last week. So this question says, oh, sorry.
I'm so blind. I'm sorry, that was really targeted.
Maybe we should back the table up so as long as that
Yeah.
that's an angle.
Oh my god.
Guys, where's the M in there?
That's a good testing.
Just Dan.
Yeah, we're Dan
Hey,
right
it's still
now.
works.
Okay, what letter is most carrying?
I still think it's a B, to be honest. Like, if they got D,
Bro,
like,
but it's the only vowel.
but sure.
But D is like the beginning.
Most, oh, man.
Okay, what letter is least carrying?
I'm not gonna lie, man.
Not gonna lie. Damn could still be down. It wouldn't be as vulgar, but it would still be damn.
All right, so
Really, bro.
That's why we only look up.
all right, so so this question says, remember last week you guys have a homework question about this one. So we're gonna revisit this question. Says they say y is equal to 4. Was y equal to square root x, and y is equal to negative 1/4 x, and they say find area bounded. Remember? So we're gonna revisit this question. There was a reason why we revisit this question. So can you guys set up for me the area between those regions? Can you draw it first and then write out the integrals, and then if you can evaluate it? But the work is a lot. And we're gonna talk about how do we make it work shorter.
Ooh, that's so easy. Always gotta start with that. Oh, I think starting with these is nice. Then y equals square root of x. That's like this, right?
No, it's not.
Isn't it like this?
Yeah.
Ah, stuff so smart. You know it's true.
Yeah, I get it.
This is more like.
Bro, I know. I'm like, what? I should have to like get into this soon.
What is this?
I don't know.
I didn't know there was one for the SAT, bro.
Oh, take the ACT. The ACT is so much easier.
Actually, but I always have more science based. I'm a science type of guy.
You're a science type of guy with the ACT. Guys, look at my graph. I mean,
Dude, I bust, bro. I ain't gonna lie. Hey, hold on, there, brother. Why you intersect right there?
Because it's still going. It doesn't just stop, does it?
And I like it this way. I'm like,
Okay, okay,
It's like,
okay. Fine.
I kind of remember what it looks like.
I'll delete just for you.
I can't believe it's only 10.
You don't have like one of those little pen erasers.
No, I need to go in those because I only like do math and 10.
Yeah.
Okay, you got that. But now I gotta find the area, right?
Yeah, let's start calculating the area. You don't believe that? Right, you might have missed that.
What is in the equal to?
Is it equals 4 equal to
Probably
square root of
Is it for both?
and then y equals 4 equal to negative.
Okay, that makes sense.
This is the one that
Is
we
it-
we like.
Yeah, sure. Well, why are you doing that? You're supposed to go to this side. Versus trying to find both sides.
Those are the
So 4 equals to 3. Also,
areas.
yeah. Yeah, they do. Yeah, they do.
Oh, yeah. I was thinking about it this morning. My mom's not trying to say. Like, you lit, like,
I also love a guy that's like, I'm gonna see you challenge.
yes,
I win.
bro. That was randomly thinking about you, reminded me of it. She's searching like a.
Okay, did you guys set up the integrals? So if you set up correctly, What will be the two integral you set up?
Negative 16
Negative 16 to what?
to 0.
To 0. And then what?
And then this 4 minus negative 1/4 x.
4 minus negative 1/4 x dx.
That's
What's
fine.
the other one? Was 0 to 16 is what?
It's 4 minus x.
4 minus square root of x dx. Okay, so the way we accumulate area is going from this. This slices from the left to right like this. Do you see that?
Yeah.
And the way we calculate, we just we integral them, so that means you adding all the lines together. So, but each line that you do, like each things that you do here, is a small changing of x. So it's dx. Dx means delta x. Delta x is changing of x. So you adding each individual slice of dx, and you adding up from negative 16 to 0. Got it? And then you say, okay, well, the calculation this is kind of messy. It's true. It's kind of messy. So that we're gonna try as much as we can. So we're gonna say that's equal to 4x plus x squared over 8, I believe, between 0 to negative 16, plus 4x minus x to the 3 over 2 over 2 over 3. And then between 16 to 0. And then the work of this is kind of disgusting because, and that's why we revisit this question. We're going to see if there's any easier way to do this question. So I plug in 0. It's going to be 0 plus 0 minus 4 times negative 16 plus 16 times 16 over 8. The reason why I write out because I can simplify it. Plus 4 times 16 minus 2/3 times 16 to the 3 over 2 minus 0. So this work is a lot. So that's going to be 64 positive. This is going to cancel out. So it'll be minus 32. And this is plus 64. And minus 4 to the third, 64. 64 times 2 is 128 over 3. Just see how much work is this. This is going to be 32 plus 64 minus 128 over 3. Well, I'm going to multiply this by 3 over 3. So it'll be 32 plus 64 over 3. And I think you're going to get 160 over 3. I think that's the final answer. Is that a lot of work?
Way too much work. Yes.
Okay. I agree with you. And not only that, you would make mistake. I make mistakes. I was doing that first period. I forgot a negative sign and screwed up everything. So let's talk about. So
Wait. 32 minus 32. Isn't it plus 32? Oh, because he added it plus 64. That's why there's only 164 in the lower one, because there's 2. How about you subtract?
64 minus 32 is 32.
4 minus 32 is 32.
because the negative signs are distributing.
Yeah. No, dude, because you're just
This negative sign distributed is one positive. This will become minus, so this is minus 32. Now, do you see that how much work to take care to do this problem? So if is it possible if I turn the paper a little bit 90 degree to, let's say, counterclockwise, is it possible if I looking at different perspective? So what I'm going to offer you, instead of looking at the dx like this way, right? It's possible to look at different perspective in terms of dy. It turns out you can. Remember, is A to B. If you want to find the area, it's gonna be top minus the bottom dx. But there's another way. How about A to B of right minus left? dy. Now remember, this B and A has to be a y bound. This has to be a y bound. So you can change everything in terms of y. If you can change everything in terms of y, it's so much easier. So let's go back and revisit this question. We say this one is y equal to square root x. Can I change that function is x equal to something? What does that change to? X equal to y squared. Good. So I'm going to change this to x equal to y squared. Is that okay? So that becomes the right part of the graph. And how about if I change this part? This part here, we have y is equal to negative 1 over 4x. And I want to change this to x equal to. How do I change this to x equal to? Negative 4y, thank you. So now I have everything in terms of y. Yes. Yes, I can. I can change that in terms of y now. Now, what else I need to change besides a function? What else I need to change? What?
Upper and lower bounds?
Upper bound and lower bound. What would be the upper bound and lower bound in this particular case? 0 to 4. Good. So the way you want to think about it, you want to accumulate area in terms of this fashion, in terms of this way. Because each line here is going to be a slice of dy. And this is not rotation yet, so we're going to get to rotation. And we can accumulate the area from 0 to 4. So what we're going to do is we're going to use this way. We're going to say, hey, the area is between 0 to 4. Right function is what? In terms of this is what? What do we get? Y squared, right? Is that okay? What is the left? Negative 4y dy. So we change everything in different perspective. It should offer me a different type of way to do something. And still gonna get result with the same answer. Now, if you turn your paper sideways, would this be on the top part of the graph and this be on the bottom part of the graph? So it's top minus bottom still. If you turn your paper 90 degrees to the right, that's still going to be the top, that's going to be bottom. So it's technically it's top minus bottom. So with that being said, hey, can you do this question now and see how much less work is this? This one's going to be y to the cube over 3 minus a plus 4y squared over 2 and between 4 to 0. And that's going to be 4 to the third power over 3 plus this one's going to be 2 y squared, so it's going to be what? 2 times 4 squared, like this. So that's equal to 64 over 3 plus 32, which is 160 over 3. See, how much work is this compared to this? So how do you be more efficient? Learning how to pick the right perspective. Now, do you remember we also give you a homework for another question? The question says y equal to square root x, I think, and y equal to x minus 2, and the first quadrant. Now I want you to do this question completely different. The work of the X perspective is all the way on the board. It's right here. I did it last week. I did this last week. It's this much work. Okay? It's this much work. Is it possible to do it in Y perspective and it's more accurate and more efficient? So is it possible to do this? So I already posted a question there. You can redraw that graph. Is y equal to square root x, y equal to x minus 2, and the first quadrant. I already told you the answer is 10 over 3. So hopefully you can get 10 over 3 out of this choice in terms of y perspective. And there is a reason why we go back to talk about y perspective, because we're already in volume. Why do we go back? Because volume can rotate in terms of y perspective as well. You have to release energy. All right, you guys done? No? Nobody got 10 over 3? Nobody? Nathan, how are you doing?
I think I'm lost, but figuring it out.
It's first quadrant.
Yeah.
Boundary near switch too. So if you switch the boundaries. So this is the area of interest right here. Charlie, no? Anthony? Got it? Ask Anthony for help.
Let's go.
Devin, you got it? Nice. Matten? No? Jorge?
Working on it.
Natalie? You got it? Chef? Almost.
I messed with the boundaries.
The boundaries switched. Make sure you have to pay attention to boundaries. Now remember, if I do it in X, right? I had to break this to two separate integrals. I had to break this to this way, and I had to do it the top minus bottom of two different things. So I have to do it here, and I have to do it another one. I'm gonna say it's another color. I'm gonna do it maybe here. So there are two separate integrals for in terms of dx, which is I don't prefer. Because if you do it in terms of dy, it's gonna be a lot easier because dy, all you gotta do is do something like this way. You can do it in terms of this way because you only had to do one integral as opposed to two integrals. So let me go show you back again. So this is in terms of dx. If I do it in terms of dx, it's gonna be between 0 to 2 square root x dx plus square root of x minus 2 dx between 2 to 4. Now this is pain in the butt because you had to deal with 4, I think 3 square root of 2, 4 square root of 2 or something like that over 3. And they'll end up subtracting each other, they'll end up getting 10 over 3. But this is too much work. There's a lot of work for this because you have to deal with two separate integrals. So let's look at this one in terms of one perspective, right? In terms of this way, let's just say, hey, let's do it this way. And if I do it this way, it's just only had to do one. And that's much easier to deal with rather than. So this is a dy. So what is top function here? So that's equal to, let's just say is equal to y equal to x minus 2. You can change that, x equal to y plus 2. And this function, you can change y equal to square root of x, change it to y. X equal to y squared. Is that okay? And I'm going to just do integral between 0 to 2. How do I know 0 to 2? I change the y squared equal to y plus 2, and I say y squared minus y minus 2 equal to 0. You're going to find intersection is y equal to minus 2, y plus 1, and then y equal to 2, and then y equal to negative 1. However, this one's excluded because we only need a first quadrant, so we actually start at 0. So therefore, it's going to be between 0 to 2. Is that okay? And top function becomes y plus 2. Right minus left. So y squared. See how easy is this? This is only one integral. So be y squared over 2 plus 2y minus y cubed over 3 between 2 to 0. I just had to plug in one number. So 2 squared, 4 divided by 2 is 2, plus 4 minus 8 over 3. So be 6 minus 8 over 3. That's equal to 10 over 3. The work is so much easier, so much more clean than the other one. Efficient way to do something, which way is more efficient? This way is definitely more efficient because the work on the board is way more complex compared to this. If you don't believe me, you can try it. The work of this is a lot more work. Any questions from here? Do you guys understand or no? Y's perspective, X perspective. Not always people need to use one way to solve problem. I don't care which way you do it, long as you do it right. You can do it in X perspective, you can do it in Y perspective, but you gotta understand there's a difference between dx and dy. And in terms of volume, sometimes you're forced, you have to use it in terms of dy. So we're gonna deal with these questions here. I forgot, this is one of the homework. Homework is gonna look like this. So y equal to x squared, x equal to -1, x equal to 4, y equal to 0. So write this down. Y equal to x squared, x equal to -1, x equal to 4, y equal to 0. Rotate around x-axis. So we want to find a volume this time. It's rotating around x-axis. So this is going to be a easy disk method. So let me see if I can do it. I'm going to draw it out. First of all, y equal to x squared. Well, I'm going to change the scale a little bit. It was from -1 to 4, right? Is that right? So they are region bounded. So I mean y equal to x squared, y equal to 0. So y equal to 0 is going to be the bound from the bottom. Is that okay? And x equal to -1. So it's going to be x equal to -1 is going to be like this. And the x equal to -4. X equal to +4. So x equal to -1 and x equal to 4. So 4 is like this. Okay, so I'm going to do it in terms of scale 4. So because I don't have enough room to draw 16 boxes. So 4, 8, 9, and 12. So 4, 4 is going to be right here. So this is going to be bounded. And this is also going to be bounded here. Now remember, we are rotating around what axis? What's the rotating? Around x-axis?
Yeah.
So it's going to be rotation, it's going to be like this. You have to be able to draw this rotation notation because this is the axis of rotation. We're going to talk about more about that tomorrow. That's going to be axis of rotation. So can you find the volume of this shape? What we learned last week is what? Two things. There was a disk method. And disk method has integration between a to b. Make sure don't forget a pi. If you forget a pi on AP exam, you're automatically done. So don't ever forget about a pi. So radius square. Or it could be a and b. If you have function in terms of y, then it's going to be like this. So this is this method you're doing today. So how would I set up this equation? What we should not forget. Don't ever forget volume. You have to have a pi in front because of the pi r squared. So I'm going to write down a pi. From what bound to what bound? What? Speak up, Devin. Devin,
Huh?
speak up.
-1 to 4.
Yeah, don't speak underneath breath. What will be the radius? What will be r of x here? What is it? It's the distance from here to here, right? Which is given by the what? Function. Good. X squared. Does that make sense? Why is a lot of you guys are afraid to say it? Now you need a square also because it's a radius square. And that's it. That's how much math you're gonna do. It's gonna be -1 to 4, x to the 4 dx pi, and that's equal to pi times x5 over 5 between 4 to -1. So that means pi 4 to the 5th power is what? Huh?
1024.
1024, thank you. And then that's a 5 and minus -1 over 5, right? So it'd be pi over 1025 over 5. So it'd be 205 pi. So the answer is 205 pi. And that is going to be the volume of the shape.
With this font,
Is that okay? X squared is given by this function. This is the distance x squared. And the x squared is acting as a radius. Sometimes radius can be different than the function. This case is just an x squared. You're gonna try the second question and the third question. Second question and third question, but start with the second one. This is part of homework, yes. Number 2 and number 3. It says y equal to x squared, y equal to 2, and they rotate around y-axis. Y-axis this time. Why do we teach y perspective? Maybe something for this. Y-axis. The boundary had a switch as well. Number 2, if you do it right, it's gonna be an even pi. So like, I don't know. Your answer is gonna be even pi.
what's the name of this lesson?
This method.
For number 2.
But I start with area, so it's not really a disk.
You have to go back and do like x equals like square root of y.
Look at them before.
Or you just leave it. You show us the one.
All right, this is the y-axis. It's rotating on y. This is the work, almost like it, on the top. It looked like a magic bullet ship. I don't know if you ever have a magic bullet before. Okay, so here it's gonna be x squared. So it's gonna be, I just have to change this to in terms of y. So it'll be x equal to square root y. And it's gonna be integral between 0 to 2 because I'm drawing this way. And 0 to 2, so it's pi. And it's gonna be square root y squared dy.
Don't forget your phone, bro. Wait, why is it?
Wait, is it even pi or it's 2 pi?
2 pi.
Okay, I feel like an even number.
All right. See you guys next time.